This is Chetan Kumar from iLearn Academy. From today onward, we will discuss about the data structure lab manual based on GCA SET second semester. So, first look on to what are all the programs we will discuss. These all are the programs which we will discuss further. So, within that, today I will discuss based on the program using the C. So, to solve linear search algorithm and binary search algorithm. So, just okay, look on to jump on the now. This is your program. Before discussing about the program, you need to know the differences between the linear search and as well as the binary search. As name implies, how the linear search is going to perform the identification operation. So, as name implies, it will be based on the sequential manner. So, it will search based on the given key with the current element from the scratch of your array element into the last one. So, lower bound to upper bound, it will going to search one by one till your key element will be identified. So, the worst case of your linear search algorithm will be the big O of n. At most, your pointer or else the index can reach up to the end. Okay, and then the element will be found at the last. So that is the worst case. And when it comes to the binary search, as name implies, your algorithm will be divided into a two half part. So based on that, the first key element will be compared with the middle element. If your key element is present at that point, the middle element, your best case will be of a big O of 1. If not, if your key element is less than the middle element, then the pointer will move towards the left aspect. If not, the other condition will be at the right side. So based on that, your binary search element will be work based on that. If your element is not identified within the middle element or at the left, your pointer will choose the third perspective, that is the right partition of the array. And since we know already your array should be in the sorted order in the term of the binary search. So just by remembering these are all the concepts, now we can start our program from the beginning. Always while you are writing the program, you will start from the library. That is the standard input output dot h. H refers to a header file. So whatever the input or else whatever the functions variables we need and which is predefined or else inbuilt, for that we need to include these kind of header files or else any kind of predefined library functions. So std means the standard. IO refers to a input output and that H refers to a header file, and by using this one we can refer printf to print element and at the same time the scanf to read the elements, okay, whichever passed by the user as the input. But when it comes to the order of execution, your compiler will choose the main function as the gateway, because the compiler will start the execution from the main function itself. So in the same order, we can discuss from the beginning of execution, that is the int main. So int refers to a return type and main refers to the gateway, because since your execution will start from this end. And after that, within the body of the main function, we are declaring our sample array with the sample elements. And what is the name of the array? ARR. Okay, that is your array name. And what is the type of that array? Integer. It means what? All the elements of your array should be within the integer format only. And you can pass any kind of numbers. That is optional. Okay, but the type should be a integer. And next later on, you are deciding the size. Okay, since you have to know its the upper bound of your array, so you need to know the size of the array. For that, we are using one of the predefined keyword as the function name, that is your size of and it is also known as the unary operator since it accepts only one variable name as the operand. Based on that, it will decide the number of byte space acquired by the data type. And within the parameter ARR refers to a type of integer. And you all know already integer will accept the 2 or 4 bytes based on the type of compiler. If your compiler is of 32-bit, it will convert in the memory space of 2 bytes. If your compiler is of 64-bit compiler, then on that occasion it will accept the 4-byte space within the same memory. So based on that, it will provide the result. Whatever the result which is provided by the size of, based on that your range will be decided within the array. And after the declaration of these variables, further we need the key as well as the result. And why we need that key? Just to choose the key element. And further the result, just to store your result values. And these both are related to the same integer format or integer type of the data. And further what we are doing? We are just acknowledging the user to do certain tasks that on end counter of the console it is indicating to input the certain elements to pass as the input. What are the input given by the programmer or as the user? It will be stored within the key named variable. And within this, the ampersand refers to a address operator. Okay, this one is the ampersand. Okay, it will store the address of that variable and it will show the path to a compiler where is the actual value being stored. And at the same time, we are using the percentage D. Whatever the operator or else operand which will start from a percentage, it will be known as format specifier. And since we are using the int, so we are using the percentage D. And even we can use percentage I. I refers to a integer again and D refers to a digit. We can use both, either the case. And based on the data type, we need to change this format specifier within the scanners. Okay, and obviously to use the printers and the scanners, we have to import, we have to include that stdio.h as a header file. And followed by, we are just deciding the result, and that result will be based on one method. And that method name is for linear search. Okay, the linear search is your method. And this method is accepting certain parameters, and those parameters of ARR, okay, that is the declaration of array, and its size based on the size of and based on the key. Okay, key is your required key element, and for these we call it as the method call. Okay, whenever the method call is encountered, your pointer or your compiler will navigate towards the actual declaration of this method. Okay, whenever method call occurs, then your compiler will leave or navigate towards your actual method. And let's move on to that part. This is your actual method. Okay, and this method obviously is accepting certain number of parameters. Okay, and that parameters of array, as we have discussed earlier, and at the same time the size. Okay, to decide the range, followed by the key. The key refers to what? The key element. Okay, this is the method you are declaring, and the int is the return type of that method. And let's start the body of that method. Within that body, we are declaring one of the variable as a local. Locally, we are declaring the variable. That variable name is I. Okay, why we are using that I? Just to refer within a for loop. Okay, just as an index, we need this I as a integer. Okay, integer type of a value. And what type of a loop we are using? We are using the for loop. And when we can use the for loop? When we have the three times. So based on the range which is known, at that time we will use the for loop. Whenever we don't know the range, at that time we will use the while loop. Okay, based on the scenario, we can switch on to the particular type of the looping the construct. And within this, obviously, we have three factors. Okay, always within the for loop, we have three factors. And the first factor is the initialization. And the second factor is the relational operator through the comparison, the conditional operation. And the last factor is your updation. And that updation will be decided based on whether your variable is incrementing or it is decrementing. Based on these two rules, you can update the element. Within the increment as well as the decrement, you can decide the priorities based on a predefined, that is the pre-6 increment or a post-6 increment. Otherwise, while you are decrementing, pre-decrement as well as post-decrement. Based on these also you can update the variable. And what is its range? Obviously, your I named variable within the loop, it is starting its range from 0 and it is ending upon less than the size. Less than the size means what? Size minus 1 or else end minus 1. Otherwise, end minus 1. Okay, these three concepts are same. And now, just we can move towards the body of the for loop. Within that, we are using the conditional statement, okay, to check the range. And while we are checking the range, we are doing one basic kind of operation, and that basic operation is comparison. Okay, we are doing comparison operation by making use of this type of conditional statement. And within this, we are using one special operator, and that operator is equality operator. Okay, because there is a difference between single equal to and double equal to. Single equal to referred as the assignment operator. Okay, just it will assign the passed value or input to the variable. Okay, and within this, we are using the double equal to. Okay, since it is also known as what? Equality operator. Equality means it is accepting the two operands. Within that two operand, we are comparing whether both are equal or not. And at the left hand side, we are using the array of I. Wherever the I is, on that value, we are comparing with our required key element. Okay, and within this, it will change for every value one by one within the array. And as we know already, within the index number 0, your first element will be stored. Within the index of 1, your second value. And so on, it will carry up to n minus 1. Your last element is being stored within the array. And based on the comparison, if your element, that the key element is present within the 0th index, it means that scenario is your best case. Why it is the best case? Because within the single instance or else within the single attempt, you got the element. If you got the element, just return onto the control as the index as a result. And this is the first scenario. What if you are not getting the element while you are traversing from first to last? At that time, your element is not exist within the array itself. Based on that, we have one acknowledgement statement, and that alternative acknowledgement statement other than the successful search is the negative acknowledgement. And that negative acknowledgement you are referencing or you are representing with the -1. -1 means what? Unsuccessful search. It means your element is not at all present within the given array. Okay, that is the operation of your linear search method. After getting the result as well as the acknowledgement, your pointer or your control will come back to this point with the result. And based on that result, again we are deciding how we can print the output. After carrying the output, it is very essential to print those output in front of the system or there in front of the console. And now we are deciding whenever your result is not equal to -1. And as I said, -1 refers to a negative acknowledgement. If it is not the negative acknowledgement, it means the search is successful. And on that perspective, you can print linear search. After that, element %d. Within that, your key element will be substituted, followed by found at the index %d, and your resultant index will be substituted here. And after that, the slash n. The slash n refers to a escape sequence character. Okay, at the time of slash n, your cursor will move on to the next line, that is new line. And the key and the result, so whatever the variable you are referencing as the output in the place of %d. In the place of first %d, the key element will be substituted. In the place of second %d, your result value as the index will be substituted. And after that, else part. Else means what? Other than the positive response. It means your search is unsuccessful. That is not found within your entire array. And this is the perspective of only a linear search mechanism. And now, after solving the mechanism of linear search, it's time to identify the same process, but we are changing the algorithm. And that algorithm name is what? The binary search algorithm. And again, it is also accepting a certain number of parameters, and that parameter is also known as the argument. And your first argument is your array, that is array name as a or you are taking. And next, size. Size refers to what? The number of elements present within your working array. And next, key. Key element is the element which you require. And based on these mechanisms, the result will be decided. And as I said, this is your function call or else the method call. Whenever this kind of method is called, your pointer or else your control will be navigated towards the actual declaration of the method. And now just jump on to the backtrack onto the actual method of a binary. And now we are looking on to the actual declaration of the method, and the name is binary search. And we already know we have 1, 2, 3. Three number of parameters. One is array, size, and the actual key element which is required. And within that, we are also declaring some of the credentials as a variable which is required as per the binary search. And we know we need one is the low. Low represents the lower bound. The lower bound or the first index within the array. And your height. Height is also referred as the upper bound. Upper bound address or the rightmost address of your array. Because to divide your array, you need these credentials. And now the size -1, that is the rightmost perspective you are declaring within the height. That is the upper bound. And followed by, you are applying the while loop. Okay. When we use while loop, whenever we don't know the range priorly beforehand, at that time we will use the while. Because we don't know still where the exact point to divide your array until and unless you know the exact number of elements present within the array. Whatever the size you have within the array, based on that you are checking. As I said earlier, to perform binary search algorithm, your elements should be in the sorted order. To verify that, to validate, to check that one, you are utilizing this condition. Always your left element should be lesser than or equal to your right element. Based on that, you are following always for every comparison, your low element should be lesser than or equal to the high. High means the upper. Okay. And after confirming this one, if this satisfies, your control will move inside the while loop as per this condition. And to divide this array within the exact half, we need this formula. And what is that formula? Why we are using? We are using to identify the midpoint. And within that the midpoint, we can get the middle element. And within that, the low plus. Within that, the high minus low. That is the range we are dividing. Okay, and divided by 2. We need the exact half of the elements to get the middle point. Okay, as per this one, we will get one certain middle element. Okay, based on that, we will apply again one more condition, and that condition will be comparison of our key element with that middle element. That is, array of mid is being compared with the key for equality. Equality of these both. If it satisfies, that is our result as the best case. Okay, always the best case will be decided based on your key element is being identified within the first attempt, first instance itself. Okay, no need to compare the rest of the element. To save that the wastage of time, we can follow these kind of algorithm. And now, if it satisfies, we can return the middle element as the result, as the index. Okay, so this is the point. If not, if your element is not present within the middle element, you can go on to the next perspective, that is else if. Else if means the other perspective. Whether we can move towards the left partition of the array or the right partition of the array. And for that, we are utilizing the second condition as the second perspective, and that perspective is if your middle element is lesser than the key element. Because first we have compared with the equality. Okay, and next perspective we are comparing with the lesser than perspective. If it satisfied, we will move towards mid plus 1. Mid plus 1 means we are flowing towards the right partition of the array on the search of our required element. And still, we are not satisfying with the second perspective also, we have other one. The third perspective, that is the greater than. Okay. If the array of mid is in case of greater than the key, it will be executed based on the else. Because as we know, if not both condition are satisfied, we have the other one as the default, that is the else part. Okay, within the else part, we have I is equal to mid minus 1. Okay, while your traversing, whenever the mid minus 1 means it is decrementing within the array. Okay, since it is decrementing, your pointer is leading towards left partition of the array. So, after following these all the scenarios, in every perspective, still, if you are not getting your element, that is the response, the alternative acknowledgement, other than the successful search, that is your minus 1. Minus 1 means what? Your key is not present within the array itself. Okay, and next step, what we will do with the result of a positive as well as a negative, we will move towards the down. Now, after getting those credentials, both the positive and the negative, we will come across to decide the format of printing the output on both the occasion. And within that, we are deciding if your result is not equal to minus 1. Not equal to minus 1 means that is the perspective of a positive response. Positive response means the search is successful. To decide that format, we can print binary search. That is the second mechanism we are working on. Element percentage %d. Within the first percentage %d, your key element will be substituted. Followed by for found at index, the second percentage D. Within that format specifier, the actual result as the index number will be substituted over there. Now this is the first scenario to format the output. And what is the second? The else. That is the binary search element, whatever the element you are expecting, that is not found. And that the key is substituted here. Okay, and at the last, overall we can return back to the overall the program after every operation has been executed successfully on the console. Enter the element to search. Okay, I am giving 50. And based on a linear search, the element 50 is found at index 4. And again, we are just changing the mechanism of algorithm linear to a binary. And we have the same result. It means both the algorithms are working accurately, correctly, but based on the efficiency, it will vary. It means when we compare linear and binary search algorithm will provide the result faster than the linear. Okay, since it will follow divide and conquer rule. Okay, half of the work is done within the binary concept. When it comes to linear, it will always search from the scratch to the last. What if your element is found at the 100th position? Okay, at that time, it will become very complicated. Okay, it will take longer time when we compare with the binary. Within that case, by using the binary, we will divide the array itself. At that time, the 15 numbers are just we can destroy, we can ignore, we can discard. Okay, because our result is at the partition of right. Whenever your element is found at the 100th position, from the beginning we can skip the first half to reach the next half. Okay, these are the comparison between a linear search algorithm as well as the binary search algorithm. I hope everyone are understood the concept. If you have any of the query, just comment me below. Okay, sure, I will respond for every of your comments.